Hey guys, so welcome back. Today we are going to create our first Solidity smart contract and it's going to look something like this. So this is remix.ethereum.org, which is a web browser based IDE, and its sole purpose is to compile code in Solidity and run and deploy it. Alright. So now, first things first, I would tell you to get familiarized with all the UI that's in here. All right. So once you are inside Remix, what I want you to do is first create your own workspace. All right. So I think you would be having some default one. But I would like you to create your own custom one. So I've just created my personal workspace and named it as CodeCove. So now once you create a workspace, it would provide you with some startup template code. All right. So it has three contracts, has some scripts for deployment and some test scripts and some artifacts. All right. So now the thing is that Remix does a lot of stuff for you automatically. All right. So like creating deploy scripts, compiling your code and building artifacts and generating ABIs. We can also do all that manually by writing our own contracts and deploy scripts and then compiling them down to ABIs using Ganache and Truffle. Alright, but that would be somewhat like an intermediate level if we talk about blockchain development. Alright, so for beginners, I would tell you to just hop on to Remix, which does everything automatically for you. So only thing that you need to do on Remix is just write a smart contract and deploy it. That's it. So all the background operations are going to be handled by Remix by itself. But don't worry if you want to know about how to create deploy scripts and how to generate ABIs manually. We'll be going through that further on in the course where we'll be using Truffle and Ganache. So obviously, just like VS Code on the left hand side, you can see all the directory structures here. So the thing is that we won't be using any of the starter template code, alright? So we won't be using any of these contract scripts and tests or artifacts. All right, so because all these are automatically created by it, so we don't even want to look at them. So what I have done is that I've created my own index.sol. So .sol is the extension for Solidity. So I've made a script named index.sol and it contains my first contract that we are going to be creating. All right. But before getting into the details of what the contract consists of, let's just first get ourselves familiarized with the rest of the UI. So this is the search tab. If you have multiple files and want to search something specific, you can go ahead and do that. Then the next one is actual Solidity compiler. So where you can actually select the version in which you want to compile your Solidity code. All right. So there are various versions that you can use for deploying and compiling your code in Solidity. So why not just use the latest version? All right. So currently I'm on 0.8.18. So I mean, why not update it to 1.9, right? So now we are on the latest Solidity compiler. All right. And you want to take the auto compiler and hide warnings. All right. I mean, if you also want to see the warnings, you can, but I just prefer not to. So I have just hidden my warnings. But auto compile is something that you always need because anything that you edit in the code, it's going to automatically compile that for you. So you don't need to come here and compile your code every time by clicking this button. Now, if you look down below, it also consists of some extra functionality. So we'll actually be going into that later on once we are on the deploying phase. So right now, I would just tell you to just, know that these things exist and just move on. All right. And the next one is actually deploy and run transactions. Now, this is where all the magic happens. All right. So now, once you get to this tab, you would be actually on Remix VM Merge. All right, so this is a local blockchain that's created for you by Remix. All right, so it consists of like 10 to 12 accounts with 100 ether, and these are all test ether. These don't have any actual value in the real world. So it has actually created some accounts for you so that you can test your applications on Remix. Then there is obviously gas limit. We'll go through that later, that what is gas. Then you have value if you want to perform some kind of a transaction and pass in a value. So you can just provide here like any number, let's say 6. Then choose the type of format that you want to pass this currency in. So this is WAY, GWAY, FINE and Ether. So the default value is actually going to be in WAY. All right. So I'll go through that later, that what is WAY and what is Ether, what is GWAY and all that. Then the current contract that you want to interact with. So this is selecting your contract in the dropdown. So if you have multiple files, you would be seeing multiple Solidity scripts here. Then we have this deploy button. All right. So you can actually deploy it onto Remix and test your own application. All right. But we are going to go through that later. Now that we have familiarized ourselves with the UI and where everything is, So let's get into our first Solidity smart contract. So this is what a Solidity smart contract looks like. So it's just a code snippet with some basic functions that we are going to deploy it onto the blockchain and then use it onto our front end. So first things first, you want to define the license that you want to use for this smart contract. So the default one is actually a SPDX license identifier GPL 3.0. I mean, this is the default one which you would see in most of the contracts that you work with. So I would prefer you for a beginner to just know that this kind of license is needed when you define your Solidity script. But you would also say that this line is actually commented out. So like, what's the purpose of writing it there? I mean, if we talk about programming conventions, then it is necessary to define the license that you are using for your code. That means that you could be using the MIT license, for instance. That means your code is open for public and anybody can do any alterations in your code. Or you could have any custom license of your own that tells you that this code is actually copyrighted and you cannot use it anywhere. So if you actually remove this line, then the Solidity compiler is actually going to throw you a warning. And if you don't want that warning, then you could obviously define the license for it. And this is the default license. All right. Now the next line is obviously the Solidity version that we are going to be using. All right. So we define it as pragma Solidity and then defining the version that we want to use. So here I have defined 0.8.11, but I also have this cap. So what this does is that it tells the compiler that at least use 8.11. And if you have any updated version, then use that, because it is possible that some functionalities could be deprecated in the previous versions. All right, because there was a very groundbreaking change after 0.5. So like before 0.5, you could not define constructor as constructor. All right, you would have to define it as a function that has the same name as the contract name. All right, so that's something that has changed through time. So it is really important to define your Solidity programming compiler version. And then we create our first contract, which I have named it as inbox. All right. So now you can compare this as a class in any other language. So like we write any other class such as class ABC in Java or JavaScript or C++. So here the class is actually contract and we define it as contract. So here you can compare that class with the Solidity contract. Alright, so we define it as contract inbox, and this would be actually a contract that gets defined in the block of a Solidity programming language. Then obviously you can define some global variables of the class that we do in any other programming language. Alright, so here I've used a string message. Now you would be thinking, what is this public? I mean, obviously it is understood that this is an access specifier. Alright, so there are access specifiers such as public and private. Alright. So now we have used public here. So the thing is that once you deploy the contract, actually this variable would be visible to public. All right. Now I would go through that later and I will show you how this is visible to public. Okay. Then we have defined a constructor of this class, very basic stuff. And then we also define a parameter that this constructor would be taking. Now, this is something new that is only specific to Solidity. All right. This keyword is called memory. So the thing is that Solidity has two keywords, memory and storage. Alright, and they are like RAM and hard disk. So memory is just like RAM. Alright, so it would just store the data for that specific function call. Alright, it won't store the data between function calls. But if you use storage keyword, then it would actually store the data between function calls. Alright, now what do I mean by between function calls? So the thing is that let's say you call set message. Alright, and you pass something as memory. So the thing is that set message will only remember that specific data until the function execution has completed. Alright. So the thing is that you pass new message, and once this function completes its execution, the new message variable is going to get dumped and it's going to get permanently deleted. Alright. And if then you try to access it in some other function, let's say get message, and you want to grab that new message variable, then you won't be able to access it. Alright. But on the other hand, if you write storage here, so the Solidity smart contract will actually store that value for you, so that in the future when you want to use that value, you can anytime come back, use another function to call that value, and it would provide you from its storage. So that's the difference between memory and storage. I mean, I know it's the first time, you won't get it the first time, but once you get into some more intermediate stuff and get the hang of it, so you would try to understand what's the difference actually between memory and storage. So let's get back to the constructor where we have initialized the global variable as initial message. So then we have created another function set message that will change the value of message anytime we want. All right. And this function is actually public. All right. So in a moment, you will understand what I mean by this public and private keyword. All right. So just bear with me. So then we have the final function of our contract that has keywords public and view. All right. So public, I mean, you will understand it in just a second once we deploy it. And view is actually the keyword that is used for functions that are not altering any data in the Solidity smart contract. All right. So as you can see that here we are actually altering the message value. That's a contract global variable. But here we are not actually altering anything. We are just returning a value from our Solidity smart contract. So for these kind of functions that do not alter any value in the Solidity smart contract have to be described as view. And obviously we are returning message in this function. So we also need to specify the type that we are returning from this function. So we would define it as returns and then we would specify in round brackets string memory. All right. And obviously you also need to define memory here so that it only stores the data for this particular function call. So now that we have created our first Solidity smart contract, so let's go ahead and deploy it onto Remix. So what we are going to do here is that first we are going to select the environment as Remix VM. All right. So it would provide you with some accounts with 100 Ether. And then we are going to select our Solidity smart contract that we want to deploy. And then obviously this deploy button has our constructor parameter, that is the initial message. All right. So the initial message that we provided here is actually being required while deployment. All right. So you actually need to define the constructor values while deployment. So I have given it a string CodeCove and now I would hit transact and it would deploy the contract for me with the constructor parameters. So once you hit transact and you don't have any errors in your code, so you would see a green tick mark inside your console. And if you scroll down a little bit and go down to deployed contracts, you would actually see your contracts that are currently deployed. So we just deployed our inbox.sol into a local blockchain that was hosted by Remix. Now, if we look at the contract that gets deployed, you would see some buttons here. All right. And these buttons are actually the buttons that were defined in our Solidity contract as functions. All right. So now if you see a set message, it's actually the set message function. If you see the get message, it's actually the get message function. Now you would say that there is no function message. Then why are we seeing message here? Now this is where the public keyword comes into play. All right. So the thing is that every variable in the Solidity smart contract is automatically created into a function. All right. So if you actually press message here, it would actually return the current value of message. All right. So this itself is a function. And now this public keyword is actually your control if you want that function to be available for public, if they want to access that variable or not. All right. So if you write public, you would actually see the button here. If you write private, you won't be seeing that button here. And in fact, the default access for any variable is actually private. So you don't need to actually write private. You can just simply remove public from here and this variable simply won't be accessible to public. So now let's try out our get message function. All right. So as we have set that message parameter in our constructor. So if we hit get message, we would get the current string that was CodeCove when we passed it in our constructor while deployment. All right. So now what we want to do is that let's change this string inside of our smart contract. So I've passed this string chillcove and let's transact it. So if you wait for some time, you would see a green tick again in your console. That means that your function has successfully executed. And now if we hit our get message function, we would get the chillcove variable. And obviously if you also hit our message, you would also again get the current value of message, that is chillcove. All right, so congratulations, you have actually successfully created your first Solidity smart contract. But the thing is that currently this smart contract is only deployed in a local blockchain on our Remix web instance. So what we want to do is that deploy this onto our Sepolia test network. So we can also do that in Remix by just changing the environment and simply hitting deploy, and it would just deploy it to our Sepolia test network. Alright, so what do I mean by that? So what I want you to do is that go to your environment and select injected web provider MetaMask. So once you select that, you would actually get a pop-up on your MetaMask that Remix wants to connect to your account. So you actually want to go ahead and do that. So now if you open up your MetaMask, so beside your account, you are actually going to see connected. So this actually indicates that MetaMask is actually connected to your Remix instance. Alright. and make sure that you have actually selected the Sepolia test network above. All right. And you would also see below the injected web provider in your remix that the current blockchain is actually Sepolia. All right. So now that we are on the Sepolia blockchain, so what we want to do is that deploy it similarly just as we did in our remix. So we are just going to pass a temporary string here, that is all the constructor values, and just hit transact. So I have actually passed the temporary string as CodeCove and I have hit transact. So once you hit transact, MetaMask will pop up again and it would show you all the gas fees that you are going to pay for it. And then it's going to show you the total fees that is going to be deducted for deploying a contract onto the blockchain. All right. Yes, I mean there is an amount fees for deploying contracts onto the blockchain. All right, and this also happens on the mainnet. All right, this is not specific for the testnet. This also happens in the real world. So if you want to deploy your application onto the mainnet, yes, you need to have some cryptocurrency in your bank account in order to deploy it. So this fees is called gas. All right, so any operation that you perform on the blockchain consumes gas. All right, so I'll just go through gas later on in the course. But for now, let's just hit confirm and deploy a first Solidity smart contract onto our Sepolia test network. So once you hit confirm, you can actually open up your MetaMask again and go into your activity tab, and you would actually see that transaction as pending. Now it is pending because it is waiting for a confirmation from the chain. Alright, because your contract needs to get added into a new block onto the blockchain. And obviously now you guys have a great understanding of how blockchain works. So you guys know that you need to wait for a block to get mined onto the blockchain in order to get your contract deployed onto the blockchain. So this would be pending for like 10-20 seconds. And after that, once the transaction gets confirmed, you would actually see your contract deployed onto the blockchain in your activity tab. So go on to your contract deployment. So this is actually the contract that you guys just deployed, and go ahead and click view on block explorer. So this will take you straight to Etherscan. All right, where you can check any transaction, any contract with its address. All right, so if you have an address of a deployed contract, or if you want to check out your any transaction that you previously did, so you can actually take the transaction hash or the contract address or wallet address and put it onto Etherscan and check the transaction history. So once you are at Etherscan, you just scroll down a little bit. You would see a from and two fields here. All right. So in the from, you would be actually seeing your own address. All right. So this is the account with which this transaction was performed. So that's why from. And the two would actually be creating the deployed contract address. All right. So this is my contract address that I just deployed onto the blockchain. So you could actually copy this address and use it as you like. All right. So you could create a front-end instance with its ABI. All right. Or you could also click on its address to check what the contract is all about. All right. So you won't actually be seeing all the code, but you can actually see all the transactions that were performed through this contract. So if you go ahead and click on your contract address, you could just scroll down below and see all the transactions that happened through this contract. All right, so you can actually see my address over here that I just created a transaction 3 minutes ago, and this is the transaction hash for it. All right, so now what I want you to do is that copy your contract address and get back to Remix. So now that your contract is deployed onto the blockchain, all it needs is actually a front end to interact with. All right. So you can either create it manually using any of the front-end frameworks that you like, or you could just simply interact with it on the Remix IDE itself. All right. So this is actually one of the biggest features that Remix IDE provides. So what I want you to do is that don't change the environment, just keep it to the Sepolia test network. Otherwise, that's not going to work because it's going to actually look on the blockchain for the specific address for that contract that it actually exists or not. And if it does not exist, then it would create your contract, but you won't be able to interact with it. All right. So select the Sepolia test network. All right. So it's going to take up your address in here, and then select the contract that you just deployed. All right. So the inbox.sol for me. All right. And actually have your contract open up in here because it actually doesn't work if you don't have your contract open up in here. I don't know why, but it's just like that. Now what I want you to do is that previously we were just simply deploying it using the deploy button over here. But what we want to do now is that we want to access already deployed contract. So what we will do is that we will actually paste our address below in the @address bar. All right, so you are going to paste your deployed contract address in here and then click @address. And before clicking @address, what I want you to do is that actually terminate all the previously deployed contracts. All right, so just hit this clear instance list and this would clear all the currently deployed campaigns and then hit at address. So this will actually create a front-end instance for the actual deployed contract on the Sepolia test network. All right. So now what you can do is that hit get message again, and this time it's actually going to take 1 or 2 seconds before it returns you the response. All right. And this actually is happening because you are on the blockchain. All right. So anything that happens on the blockchain, it's going to take some time because it's going to get registered as a transaction onto a new block. All right. So once you hit get message, it's actually going to go onto the blockchain and it's going to go as a transaction. So everything that happens onto the blockchain happens as a transaction. So you would need to wait for the response from the blockchain until it gets back to you. So you would need to wait 1 or 2 seconds, and then the response would be returned as CodeCove. And the same would happen if you hit the message button. All right. So now let's just set a new value for our message. All right. So let's just set it as ChillCove again. All right. So I have passed the temporary string as ChillCove, and now let's hit transact. Now what's going to happen is that your MetaMask is going to pop up again. All right. Because it's going to get registered as a transaction, and this time as we are changing some values in our smart contract, so we are actually performing some operations on the blockchain. All right. So every operation that you perform on the blockchain is going to consume some gas. All right. So again, when the MetaMask actually asks you for a confirmation, it would actually tell you that what's the gas fee is going to be. All right. So for me, it's going to be a value that is really less and close to zero. But yes, you would have to pay some amount of cryptocurrency in order to perform a transaction on the blockchain. So once you're satisfied with the gas fees, you could actually hit confirm and then patiently wait for your transaction to get mined onto a new block. So if you just open MetaMask again, it's going to show you that the transaction is currently pending. So as you can see here, my set message is currently pending, and just now it just got confirmed on the chain. Alright, so now I have a confirmation of the set message. So you can also check it on the block explorer, go on Etherscan and check the transaction hash and who performed the transaction. So now again, if we hit the get message function and wait for 1 and 2 seconds, you would get the response as ChillCove, and the same would happen for the message button also. Alright, so now we have successfully deployed our first smart contract onto the Sepolia test network and interacted with it onto our front end with the help of the Remix IDE. So obviously I would be providing the Remix IDE link down below in the description, but I also will be providing an extra link which is obviously necessary for you guys, because I obviously have some Sepolia test ether in my MetaMask account, but you guys don't. All right, so you guys need to get some Sepolia ether from somewhere. All right, so I would be providing 2 links down below where you can get free Sepolia ether for yourself. So first link would be actually where you would be asked to create an Alchemy account, and you would actually be provided 0.5 Sepolia ether per day. All right. And the other one is actually going to be a Sepolia faucet where you can actually enter your wallet address and mine some Sepolia ether for yourself. All right. So I would be providing those 2 links down below. So go ahead, mine or get yourself 0.5 Sepolia ether just by creating an account on Alchemy. And once you have some Sepolia test ether, you can go ahead and create your smart contract, deploy it onto the Sepolia test network, and obviously test it out in the Remix IDE. So now we'll be moving on into clearing out some terminologies for a Solidity smart contract. And once we are done with that, we are actually going to start our first Solidity smart contract project. All right, so that's going to consist of making a Solidity smart contract and obviously attaching our own custom front end to it and creating a full stack Web3 application. So I'll see you in the next one, and until then, keep chilling at the CodeCove.